Hello, dear friends. Warm welcome to you all to the channel World of Zoology. This is our next lecture from the series Instrumentation, and the today's point of discussion is chromatography, which is a laboratory technique for the separation of the component from the given mixture. Here we'll consider following points: principle and application, types of chromatography, its introduction, and last one, the application in short. What is chromatography? First of all, it is a technique used for separating different components from the given mixture. The Russian botanist Mikhail Tsvet coined the term chromatography for describing his experiments on separation of different color constituents of leaf pigments by passing an extract of the leaves through a column of calcium carbonate, alumina, and sucrose. In his work, he separated compounds appeared as colored bands in the column, and therefore he chose the name for the method from the Greek word chroma means color and graphen meaning to write or to paint. His work went virtually unnoticed for decades, but today chromatography is probably the most important technique employed in analytical chemistry. The first analytical use of the chromatography was described by James and Martin in 1952 for the use of gas chromatography for the analysis of the fatty acid mixtures. Now we'll consider principle of the chromatography. Solutes can be separated from each other on the basis of their differences in affinity towards the moving or the mobile phase, and the another is non-moving or stationary phase. The mobile phase may be gas or liquid or even a mixture of the various liquids, while stationary phase may be solid or liquid. The nature of solutes, mobile phase and stationary phase are important for effective separation. Solutes traveling in the mobile phase interact at the same time with the stationary phase. Solutes moving rapidly are hereby separated from the solutes that move slowly. Each solute distributes itself between the stationary and the mobile phase, that is, it equilibrates between the two, stationary and mobile phase. The distance a solute moves is always the same fraction of the distance moved by the solvent, because solvent carries solute along with it. This fraction is variously called the retardation factor or resolution factor, and which is given by the symbol R or RF, and may be described by the equation RF value is equal to distance traveled by the solute divided by the distance traveled by the solvent. Now we'll consider types of chromatography. Since a good variation is possible in the selection of the mobile and stationary phase, it is possible to have different types of chromatographies on the basis of the phase combinations which are used. First one, that is liquid solid chromatography. In this, mobile phase is liquid and stationary phase is solid. For example, a piece of chalk can be a solid phase, and a suitable solvent such as water or which is used as the mobile liquid phase. An example could be the experiment which is performed by the Tsvet, wherein he used calcium carbonate as the solid phase. Second one, that is liquid-liquid chromatography, which is also known as partition chromatography. It is based on thin film formed on the surface of the solid support by a liquid stationary phase. Means the stationary phase is also liquid, which is formed on the surface of the solid support. The solute equilibrates between the mobile phase and stationary phase. third one, that is gas solid chromatography, in which the stationary phase is solid packed in a column and a gas is the mobile phase. Means stationary phase is packed in the form of the solids in the column and gas is the mobile phase. Now the fourth one, that is gas liquid chromatography, has a gas on mobile phase while liquid acts as the stationary phase. In gas liquid chromatography, liquid is stationary phase whereas gas acts as the mobile phase. In chromatography, the separation occurs on stationary phase, while the mobile phase helps in partitioning the solute in dynamic equilibrium. The process by which stationary phase causes separation of solutes may be either by the way of adsorption, which is physical phenomena, or by partitioning the solute with the mobile phase. Hence, chromatography may also be classified as adsorption and partition chromatography. We'll consider first, that is adsorption chromatography. In adsorption chromatography, separation of compounds in a mixture is based on the relative difference in adsorption of component on the stationary phase in the chromatographic column. Here, the molecules or components of the mixture travel with the difference rate due to the differences in their affinity towards the stationary phase. Means the differences in the affinity towards the stationary phase is responsible for the um, traveling rate of the component of the mixture. Adsorption means a physical attachment of the compounds on the surface of the stationary phase. Here we will remember that the adsorption is physical phenomena and here attachment is physical attachment of the compounds on the surface of the stationary phase that takes place. Based on the nature, polar bonds adsorb with the stronger or greater intensity to the polar stationary phase, while nonpolar compound adsorb better to the nonpolar stationary phase. Means polar bonds are formed with the polar stationary phase, whereas the nonpolar compound they adsorb better on the nonpolar stationary phase. Hence, during separation of the compounds, when we use a polar stationary phase, polar component elute out late due to the greater affinity to the stationary phase than non-polar component of the mixture. Means when we use polar stationary phase, the polar component elute out late due to its greater affinity to the stationary phase compared with nonpolar components of the mixture. This means that the nonpolar solute elute out first. This is reverse in case of the case when we use nonpolar stationary phase. Here adsorption chromatography is shown where solvent is at the top and mixture of the component is in between the stationary phase and solvent, that is which is at the top, and separation of the mixtures on the adsorbent, that is on the stationary phase, takes place as the solvent passes through the adsorbent and then separation is carried out, and for which there is a plug at the base. Now we'll consider the second one, that is thin layer chromatography, which is based on the principle of the adsorption chromatography. The stationary phase is thin layer of solids such as alumina or it may be a silica supported on the inert base like glass, or it may be inert base may be aluminum foil or insoluble plastic which is used as a base. The mixture is spotted at the bottom of the TLC plate and allowed to dry. But the spotting of the mixture is done above the level of the solvent. The plate is placed in a closed vessel containing solvents, that is mobile phase, so that liquid level is below the spot, otherwise liquid will be in the solvent itself, or the dissolution of the stationary phase may take place. Due to that, the mixture may get dissolved in the solvent. TLC has advantage over paper chromatography in that its results are reproducible. The separations are very efficient, and even the speed of separation, that is time required, is less in case of the TLC compared with the paper chromatography because of the much smaller particle size of the stationary phase. The solvent ascends the plate by capillary action, the liquid filling the spaces between the solid stationary particles, and then solvent ascends that particular plate by the capillary action. This technique is usually done in closed vessel so as to ensure that the atmosphere is saturated with solvent vapor. When we close the particular waste paper, saturation of the solvent system takes place due to the vaporization of the organic component which is present in the solvent, and that evaporation from the plate is minimized before the run is complete. We'll have to mark the solvent front as early as possible when we remove the plate out of the container or chromatography chamber. The plate is removed when the solvent front approaches the top of the plate, and the position of the solvent front is recorded before it is dried, because drying takes place very fast. This allows the RF value to be calculated. We need for the calculation of the RF value distance traveled by the solute divided by the distance traveled by the solvent, and therefore we'll have to mark the solvent front as early as possible when we remove the plate from the chromatography chamber. Now we'll consider application of the TLC. That is the next point of the lecture. TLC has application in detection of a given solute on the basis of its RF value. Then second one, it can also be used for effective separation of solutes like other type of the chromatography. Third one, in laboratory, it can be used to study the progress of the chemical reactions, ascertaining the purity of the given substance or the molecules. Here the TLC plate is shown where the separation is carried out. We can observe the solvent front at the base, one spot greenish in color, and then the component gets separate as the solvent system ascends the chromatographic or TLC plate, and separation of the mixtures or the component from the mixture is carried out as the solvent moves in upward direction, and we can then measure distance traveled from the point of the spot to that middle of the particular point which is separated. Here which is shown, the four spots are we can observe on the chromatography plate, glass plate, that is TLC. Now we'll consider third one, that is partition chromatography. Partition chromatography is also called as partition coefficient chromatography because separation of solute depends upon its ability to get preferentially distributed in a given phase such that the phase is either liquid or it may be a gas. Such distribution obeys Nernst law of distribution given by the equation K is equal to C1 divided by C2, where K is the partition coefficient and C1 and C2 being the concentration of the given solute in phase 1 and phase 2 respectively. Separation occurs when the solutes in mixture get distributed into two liquid phases due to the differences in partition coefficient, that is K, during the flow of the mobile phase in the chromatography column. Here the solute molecule gets preferentially separated between the two phases, which depends upon the partition coefficient K. That is, C2 will be greater than the C1. A general rule of solubility, namely like dissolves in like, means the organic solvent, suppose then the particular solutes which are dissolved in the organic solvent are different from that of the aqueous. A general rule of solubility, therefore, like dissolves in like, make it probable that the polar solute prefer polar phase, whereas the non-polar solute prefer non-polar phase. Helps to understand the separation by the partition. Here partition chromatography is shown where the sample start point is there above the solvent, and then separation is carried out. We can find here the 4 spots and the distance that is measured from the sample which is loaded on the solvent front. That is baseline, what we term it, and then it moves toward the last point, what we term it as the solvent front, and we can calculate the RF value. Then the next is the paper chromatography, which is old and simple one. It is probably the first and the simplest type of the chromatography. Here water in the solvent entrapped in the capillary columns of the paper that acts as the stationary phase. Means water molecules in the solvent which are entrapped in the capillary columns of the cellulose paper that acts as the stationary phase, and the organic solvent that act as the mobile phase. A drop of solution of a mixture is placed on the piece of the paper, that is chromatography paper, on the baseline, and then it will be allowed to dry. The mixture separates as the solvent front advances and it passes up the mixture, and when the chromatography paper is brought in contact with the mobile solvent phase, that is solvent system. As long as the correct solvent and chromatography paper are used, it may be possible to identify solute from its RF value, since this RF value for a given solute is constant for a given solvent and a given paper type also. That is, RF value is specific for a given solute, and it is constant for given solvent system and also for the type of paper which is being used. Different solvents may be used as the mobile phase, such as butanol, acetic acid, acetone, ethanol, then chloroform, which are used as the solvents. Sometimes a mixture of solvents including aqueous solution containing dilute mineral acids or dilute bases like ammonia are also used as the solvent system. Watsman's filter paper is used as the chromatography paper for routine and quick experiments, and this method may be used for separation of the amino acids from the mixture of the particular mixture which is being analyzed. The paper chromatography is shown here, where the sample is loaded on the baseline and the tip of the paper is deep in the solvent system, and then that particular mixture is allowed to run along with the solvent system up to a particular point, and then we can remove the paper from the container or chromatography chamber, and immediately we can mark the solvent front and can calculate the RF value. And here the leaf pigments are shown with different RF value. Different pigments are having different RF value, and which is shown here in this diagram: chlorophyll B, chlorophyll A, xanthophyll, and carotene, etc., with its different RF values which are constant. We'll consider the various uses of the chromatography in short, because chromatography is very useful in our everyday life. The process which is used to find out what substances are composed of by separating the components or the compounds into their various components, and its use that affect everything, what you eat, what you fight, when you fight the diseases, like that. And there are applications of the chromatography in the everyday life, such as creating vaccines. Chromatography is useful in determining what antibodies fight various diseases and viruses, and therefore scientists use chromatography in the fight against the various preparation of the various vaccines. Also, the second application of the chromatography in everyday life is for food testing. We can use chromatographic techniques for the food testing. The traditional method of analysis were effective for determining the composition of the raw samples, but nowadays we can use high performance liquid chromatography combined with mass spectrometry, and successfully, which is used to find out the meat that had been labeled as a beef was beef, horse, or a mixture of the various types of the ingredient. We can find out with the help of the chromatographic techniques. Also, bioreagents testing is carried out with the help of using chromatography. Many drinks manufacturers use this technique to ensure each bottle of their product which is exactly the same or not, in that case. Also, the drug testing uses chromatographic techniques. Accurately, the chromatography can identify the substance within the bloodstream, or it is widely used in the sport to test the athletes for dropping or doping, sorry, or performance enhancing drugs which are used by the athletes during, so as to elevate their performance. Then also chromatographic technique is used in the forensic science for testing. Chromatography is used to help the to catch the criminals in forensic science. Um, and here we can finish the various applications of the chromatography, or summarize in short the applications of chromatography and its usefulness in everyday's life. Thank you for watching my video. If you like the video, do like, share the video for the benefit of the maximum students, and subscribe the channel World of Zoology for the notification of my further video on the last point from the unit instrumentation, and that is nothing but the pH meter. Thank you once again. एस्केप करायच्या ऐवजी इथे ह्याच्यावर बोर्ड गेलं. बघते मी आता.